The desirable properties of dosimeter are characterized by precision, linearity, dose rate dependence, energy response, and directional dependence. However, the response of dosimeter depends upon their construction, physical dimension, and angle of incidence of the radiation. It is imperative to quantify their desirable characteristic before the actual use and apply the necessary corrections.
The first dosimetric property is resistivity. Electrical properties of semiconductor can be indicated by resistivity. Conductors such as gold, silver, and copper have low resistivity and can conduct electricity easily, while the insulator such as rubber, glass, and ceramic have high resistivity and are difficult for electricity to pass through. Semiconductors comprising a single element are called elemental semiconductors, including the famous semiconductor, which is silicons. Semiconductors have properties somewhere between these two. Their resistivity might change according to the temperature. At low temperature, almost no electricity passes through them, but when the temperature rises, electricity passes through them so easily. The second property of semiconductor is energy dependence. Energy response is an important characteristic of a dosimetric system. Dosimeter may exhibit energy dependence, particularly for low energy beams, due to their high atomic number. It is difficult to find a dosimeter that is tissue equivalent and energy independence over the entire energy range used in radiotherapy. A study by Satish Kumar et al. They investigated the energy dependence of the MOSFET dosimeter for cobalt-60 gamma rays and 650 MV X-rays. In this research, the performance characteristic of mobile MOSFET dose verification system was analyzed for megavoltage photon beams. It was observed that the MOSFET response is energy and dose rate independent for measurements at depth beyond dm. Hence, this dosimeter can be used over a range of photon beam energy with no correction for energy and dose rate dependence. The third semiconductor property is dose rate. In an integrated system, the dosimeter response should be independent of the dose rate at which the radiation dose is delivered. The dose rate dependence of the dosimeter should be checked and appropriate correction should be applied in order to investigate the dose rate dependence and response. The reading for dose rate by using MOSFET dosimeter were obtained by irradiating them to 100 centigrade for dose rate by using 6 and 50 MV photon beams. It is observed that the MOSFET response is independent of dose rate variations and for variable field size. From previous study, There is a linear increase of semiconductor signal with temperature. The correlation found between the temperature and dose rate dependence points to a common basic physics phenomenon at their origin, probably related to the minor carriers in the crystal. While with the temperature, the higher the increase with dose per pulse, it is observed that there is a large dependence on dose per pulse for N-type and a negligible one for P-type diodes. The other dosimetric properties of semiconductor is reproducibility, at where the semiconductor detector have excellent reproducibility, good mechanical stability, absence of external bias, small in size, and the energy is independent of mass collision stopping power ratio between silicon and water for clinically usable electron beams with energy 4 to 20 MeV.